All right, so we'll put off the quiz until everybody else is here. Chickens. All right, so we're gonna finish up the chapter today, right now, and probably start chapter 3. Transformations. A transformation, as you said yesterday, is a change. That's come in the movies. The Transformers, what do? They change from cars to monsters and monsters to cars. So it's a change. It's a transformation. In mathematics, there are four major forms of transformations. Of algebraic functions. There are four major types. So, but before we begin, let me give you what a function really looks like. Because right now, the first thing we talked about, if I ask you for an equation in math, you'll give me this one. Even though we talked about the point slope formula, the slope intercept formula, the standard formula, all these other ones. But this is the one that people spit at me. But it's not a function. Okay, so if we make it a function, this is a function. But again, not much happens there. Because what's the only thing important in this function? M and B, the slope and the y-intercept. Oh, that's pretty boring. It doesn't talk about all the other functions we have in our library of functions. This is what a function looks like. This is the function we're going to talk about. Where A, B, C, and D are real numbers. The reason they have to be real numbers, because we can't graph them if they're not. Can you graph an imaginary answer? You could in your mind, but I couldn't see it. So this is what the whole thing, and we're going to talk about what each one of them do. So the four types. The first type is we're going to talk about is the horizontal shift. The left and right movement of the function. Out of this whole thing, that's defined by C. Your C term, this one right here, that defines what your horizontal shift is going to be. The next thing we're going to talk about is a vertical shift. So which one do you think is a vertical shift in this equation? D. Just think about it. Horizontal shifts affect the x values directly. It affects the x values before you plug it into the equation. The vertical shift is after you get your number from your equation, it moves it up and down. So all it does is affect the y value. So horizontal shifts occur inside the function f of x. So instead of writing the function inside f of, actually I would say inside f of x. If it's a vertical shift, it occurs outside the function. Because the vertical shift affects the y values, the answers. That's why it's outside the function. I get a value for x. Remember I'll define this in a second. Well, I'll do that now. Remember, x is the independent variable and y is the dependent. Because the value of y, you can't figure that out until you tell me what x is. So once you pick a value for x, you put it in the function, and that gives you an answer. Now, if it happens outside, once I finish getting the answer from the function, I either go up or down from that point. That's a vertical shift. And this is always true. Anything horizontal occurs inside the function. Anything outside the function affects it vertically. The third transformation horizontal, shrink, or stretch. What does that mean? Horizontal, shrink, or stretch? Well, what it means is this. Let's say we had this function. What is that function? No, it is. What's the equation? What is it?
What is it?
It's x squared. Again, I want the people who don't know to answer. The three of you all who know it, I don't know why you're in this class sitting down anyway. I'd be asleep right now. If you're spitting out the answers, you know it. Stay home and do the work. You guys should finish the semester. Work ahead. Finish a semester. You can do that. There's not a penalty. If you know this stuff already, go ahead and work on it. Stay home. Watch TV. But this is a parabola. It's a quadratic equation. The equation is x squared. Now, horizontally, if I shrink it, it'll look more skinny. I'm pushing it horizontally. I'm shrinking it. And the stretch is I'm pulling it out this way. So that's what the changes are horizontally to the graph. And that is mostly what B does. The coefficient of x. And here's another hint for you all. Remember when we did circles and we asked you to find the center of the circle? And I gave you something like this. X plus 2 squared plus y minus 5 squared equals 4. Where was the center? This is chapter 1. Where was the center of that circle? That? No, the three of you all, I don't want to hear from. I want to hear from everybody else in this room. I don't want to hear from the same three people over and over and over and over because you're ruining it for everyone else. If you keep on doing it, I will ask you to leave because you're learning nothing. If you know it already, you're learning nothing. impress me. Finish the course early. That will impress me. So what was the center of the circle? Just 2? No. Remember, the center has to be a location. It's the H and K. -2, +5. If you look back on your notes, look at this back to the lectures. How do we find the center? You take these numbers, set them equal to these equations, set them equal to 0, and that tells you the answer. You notice it's +2, the answer is -2. It's -5, the answer is +5. Whenever anything happens inside, it's always the opposite. Whenever anything happens on the inside, it's always the opposite. I'll put that in there. Any change inside the function results in the opposite way. So if I ask you for the center of the circle, you took +2 and you made it -2. That's opposite. You took -5, made it +5. And we're going to talk about this because of the value of b. If b is an integer, it'll make the function skinnier instead of bigger. If b is a fraction, it'll make it wider instead of narrower. So that's an important note. And then last transformation we're going to talk about is the vertical shrink or stretch. If it's vertical, where does it happen? What's that? No, if it's vertical, where does it happen inside the function? Here's our function. Where does it happen? If it's vertical, it happens where? If it's vertical, it happens outside the function. So any change to the function happens outside. So A is going to be our vertical change. There's a fifth one that we're going to talk about that is a form of transformation. We call those reflections. Reflections occur with A and C. Or not C, but B. Sign change of X. So which letter would be a sign change of X?
Would be B, right?
It would be, yeah. So it's either going to be B is going to be positive or negative. So this is the B value. Sign change is the B value. This flips across the y-axis. So if x changes from positive to negative, your graph now, instead of going to say, it's like the square root function, instead of going to the right, it now goes to the left. So this reflection, I'll call it a flip. Sign change of the y variable. What letter is that? A, B, C, or D? A. Because remember, f of x, this is your y value right here. A is the coefficient. This is either positive or negative. That makes your y values positive or negative. Remember, y is the same thing as f of x. There's your f of x. So if a changes from positive to negative, this one flips across the x-axis. Remember, if it happens to x, it's horizontal. So if the only flip we can do in the horizontally is across the y-axis. If we change the y value from positive to negative, what that changes is across the x-axis. So these are the things we're going to look at today. And more if we have time. What's that? Good question. The question was, is reflection like symmetry? The answer is yes and no. Because you can only be symmetric. I say only, but what's that function? Again, I don't want to hear. I don't want if I have to keep on saying this, I will ask you to leave. It's square root, right? Because you obviously know it. Why are you sitting in class? What's the reflection for that one? If I reflect it over here, what happened? How do I make it go this way? What would that look like? So what happens to x? X changes sign. Think about it. If it's horizontal, x changes signs. And x is inside the function. It used to be positive. Now think about it. Can I take a square root of a negative number? So the only way I can get rid of this negative is if x itself is negative. So if I have the square root of negative 4, negative becomes a positive, I get 2. So because of this negative here, I have to make x negative, so it flips across the y-axis. Again, it's a horizontal flip because the change happens inside. If I flip across the x-axis, what happens to my values there? Is x changing or is y changing? Yeah, at 4, the answer is 2. So at 4, it's going to be -2. So what happens here, because it's a vertical change, it happens outside the function. So the negative is outside. So this is what you have to be very careful about. What kind of effects do these negative signs have? And whatever is in front of the x value is my b value. Whatever is in front of my function is my a value. So that's what we're looking at there. Those are reflections. So let's look at example 1. Sketch the following. Don't go looking through it. Just follow what's on the board. All right. The way we sketch these is we have to start off by building up to our equation. Always, the first step, make this A. The first step, what is the function? What is the original function of this equation? Remember, this inside this equation here has to be one of the functions from the library function sheet we have. So what's the first function? What's the basis of this? What's that? Instead of the name, give me the function, the equation. What's the equation for quadratic? X squared. So x squared is my function. That's right there. So what does that graph look like? It's a parabola. Very good. You see why I want you to memorize that chart? You could start building these things once you know what they look like. Okay. Now, the next thing you look at is, does x change values? Remember, the function is x squared. Is there any change going on inside the function? No, it still says x squared. This happens outside. So first, next off, is there a horizontal shift? No, because there's no change on the inside. Is there a vertical shift? In other words, is there anything happen outside the function? Yeah, we have x squared minus 6. So here's our original function. What happens to it? What does -6 do to it?
Goes from negative to positive.
What letter is this in the whole scheme of things? Remember, our equation was, what letter would this one be? It's D. It's outside the function. So look at your sheet. What does D do? Where? All these shift. It shifts vertically. So the graph doesn't change shape or size. Only thing happens to it is I change the origin from there to there. I'm shifting the origin from here to here. My graph still stays the same. All I did was change the origin. I moved it from 0, 0 to 0, -6. So there's the graph. How about this one? So again, first thing I'm going to ask you, what's the library for the basic function? The function here is the absolute value of x. Because your first step is to locate this function on that chart, or in your memory, I hope. So what does that graph look like? Aren't you guys have a quiz this morning?
Like a movie.
It's a V. Now looking at this, the next part of this change, this transformation, is it inside or outside the function? Remember, the function is absolute value of x. What are we doing to x? Are we changing x or are we changing y? We're changing x because before we can take the absolute value, what do we have to do? We have to take whatever x is and subtract 4 from it. So this is a horizontal shift because we have to move it horizontally. It happens inside the function. Okay, so since it's a horizontal shift, which direction and how many spaces? It's happening inside the function. So it's what kind of shift? Horizontal. So horizontal means left and right. Is it moving left or is it moving right? And how many spaces? Let's see. X minus 4 equals 0. X equals 4. We just talked about this. It's always the opposite if it's internal. So we're moving 4 spaces. It's positive 4, so we're moving 4 spaces to the right. If it's inside the function, it's always the opposite. So it's a minus 4, so it's 4 spaces to the positive side. Again, all we've done is move the origin from here to here. The graph hasn't changed shape yet. How do we know the graph hasn't changed shape? Because there's nothing in front of x and there's nothing in front of the function. The next one, g of x, the square root of x plus 2. So the first thing I ask, what's the basic function? The square root of x. Very good. What does that graph look like? Nope. Starting from where? Starting from 0, 0, it's like a swoosh mark. Yes, you guys should be breathing a sigh of relief. I'm not going to have a quiz this morning because the quiz would be a major grade. You see how important it is to know these graphs. Okay, so what's the next shift? What's the next change? Is it horizontal or vertical? Why? It's inside the function. So it's a horizontal shift. This is a horizontal shift. All right, so how many spaces, which direction horizontally? How many spaces? Yep. Because we move, it has to be -2 to the left. So here's my new origin. The graph looks the same. There's your graph. How about this one? So whenever you look at transformations, you work inside out. First off, what's my function? Actually, let me change this one. It's a cube root. So what's the basic function? The cube root of x. What does the cube root of x look like? What's that? Like an S, yeah. Squished out, right? Then we can make a checklist. Is there a horizontal shift? Is there a horizontal shift inside here? How many spaces where? Yeah. There's a horizontal shift because because what's happening here? A horizontal shift, if I change x, before I can take the cube root, I have to take whatever x is, I have to add 2 to it. So I'm changing my input, and then I take the cube root of it. So which direction, how many spaces? Yeah, because it's +2, I'm going -2. So my origin has shifted to there. I moved it from 0, 0. I moved it to -2, 0. Okay, so that's this part. Is there anything else? In our equation, we have a -3. What does that -3 do? What kind of shift is that? It's a vertical shift. Why is it a vertical shift? Because it's outside. It's independent of the function. So what does it tell me to do? Shifts down. The vertical shifts are what they are. If it's negative, it means you go down. If it's positive, you go up. Horizontal. The inside of the functions are always opposite. So our horizontal shift is 2 to the left and 3 down. So there's my new origin. So the graph looks the same. It just goes through there. Does that make sense? Again, you have to memorize those charts, those graphs. Let's look at another one. How about this one? First question, what function from the library function does this one look like? Okay, there's 2 of those. Which one? Yeah, it's rational because x is on the bottom. Very good. But which one of the 2? because obviously they both look different. One over x squared, because here's the x and it's squared. So what does that graph look like? What quadrants?
The one.
Yeah, it's the Atari symbol. Okay, so we have the basic function. We ask, is there a horizontal shift? Is there a horizontal shift? Well, yeah, because it's inside the function. The function is squared. It's inside there. So it's a horizontal shift. How many spaces, which direction? How many spaces? Yep. Because it's +3, might have to go -3. So there's my new origin right here. So the graph looks like this. We have 1 over x plus 3 squared plus 2. We talked about this one already. There's nothing else in there. So what's the next shift? Yeah, it's a vertical shift 2 up. It's a vertical shift. So we go 3 to the left, up 2, and then this is my new origin. The graph looks the same. I haven't changed the graph. The graph will always have the same basic shape. It's just all we're doing is changing the location of it. All right. So let's look at reflections. Remember, we have two types of reflections. We have a horizontal reflection and a vertical reflection. What causes a reflection? So this is our equation of our function. So what causes a horizontal reflection? What causes a horizontal reflection? Can't, which one? Nope. Nope. We're looking for horizontal reflection. Only horizontal. Where do horizontal changes occur? Yeah. Inside the function. So we only have two letters inside the function. Which one's going to make a reflection? B. If B changes sign. In other words, if your coefficient of x becomes negative, then we have a horizontal reflection. What's a vertical reflection? If the function itself, if A changes sign. Example 2. Again, I don't like this one because we haven't learned polynomials yet. So what I'm going to do with this one, let's look at this one. So what do we notice is about this one? Right. The function is square root of x. So we know the basic function looks like this. Right. What's the next thing we notice? We observe. Is there a horizontal shift? Which direction, how many spaces? Yeah, because you take this equation inside there, set it equal to 0. So you have 2 minus x equals 0. So 2 equals x. So it's 2 spaces to the right. Is there a vertical shift? No, there's nothing outside the function. But inside the function, we notice that x has changed signs. Because in this original function, it's positive. If it becomes negative, what do we have to do? Since x changed signs, it's got to change direction. It's a horizontal reflection. Think about it. Can we use the number 3 in our equation? 2 minus 3 is -1. Can't take square root, so we can't take anything bigger. Can we use 2? Yeah, 2 minus 2 is 0. We do that. Can we use 1? 2 minus 1 is, yeah. So we can only take numbers that are less than that. So if x changes sign, you change direction left and right. Let's look at another example. How about this one? The first thing, what's my original function? X cubed. What does that graph look like? Yeah, it goes up. It's the same as x squared, except we can have negative answers. So we put that one down. That's come. It looks like this. All right. Do we have a horizontal shift? It's which direction, how many spaces? It goes to the right, 3 spaces. Good. 3 minus x equals 0, so 3 equals x. So my graph now is over here. What else do we have? We have a horizontal reflection. Because x is no longer positive, it's now negative. You have to build out. You're not even done inside there yet. We have x cubed. We should have done this one first, really, but let's do the shift, which we did here, which was 3 minus x squared, or cubed. Now we have a horizontal reflection. Two, three. So it reflects horizontally. So the graph now looks like this. I take all the positive x's and make them negative, make them negative x and make it positive. Now we finished inside. There's nothing else we can do inside. Now we can do the vertical shift. Because it happens outside. One, two, three. So it goes over 3 and up 1. So there's my new origin. The graph looks like this. I'm giving you a very rough sketch here because what you should do is now what you know where the center point is, this is the origin. It used to be here. It now shifts there. Plot some points so you know exactly where it goes. So far, so good. But again, you have to memorize those tables. It makes life much easier for you. So you have vertical shrink or stretch. Where does the vertical shrink or stretch? Which variable would that one be? So which one would be a vertical shrink or stretch? Yeah, because it has to happen outside the function and it has to affect, since it's shrinking and stretching, it has to affect the y values directly. That's why D, all it does is go up and down. That's all. It doesn't change anything. It just changes location. A now changes the shape of it. So this is the shift that we're going to be looking at now. If the absolute value of A is greater than 1, we have a vertical stretch. Why is it vertical stretch? Because this A, if my value originally was 1 and A was 3, I now take this y value, I multiply it by 3. It's up here now. So it goes up vertically. So if my coefficient was 3, I take whatever y value I have and multiply it by 3. So 1 times 3 is 3. That's my new shift. If the absolute value of A is between 0 and 1, meaning it's a fraction, then we have a vertical shrink. So what if my equation, and this one here is y equals 3 f of x. Since it's an integer bigger than 1, if I start off at 1, 1, this one says I take whatever I have for my y value and multiply it by 3. It goes from 1, 1 to 1, 3. This one, if it's between 0 and 1 means it's a fraction. Let's say half. So what that does, if I have a point, this is my f of x. If it's at 1, 4, and I have a half in front of it, what does it become? Here's my y value. My y value is 4. F of x is your y value. What's 1/2 of 4? 2. Because it's a fraction, that means my points get pushed down. They get shrunk, constricted. Remember, whatever happens outside the function, it is what it is. If it's a big number, it goes higher. If it's a small number, it gets shorter. Let's look at some examples. No, we'll do that. We'll do the sheets I gave you a second ago. We'll do that one there. So that's a vertical shrink. It's the A value. It's whatever coefficient is in front of your function. Actually, we could look at an example here. F of x equals 3 absolute value of x. So my first question is, what's my original function? Absolute value of x. What does that look like as a graph? It's a v. Very good. Which means, let's see even closer at that. When x is 1, y is 1. When x is -1, y is -1. When x is 0, it's 0. When x is 2, y is 2. When x is -2, y is 2. So that's the absolute value of x. Is there a horizontal shift? None. Because there's nothing changing on the inside. Is there a vertical shift? No, there's nothing plus or minus to it. Is there a reflection? No, because X doesn't change signs, neither does Y. So there's none. So far, the function stays the same. Now, is there a vertical shrink or stretch? Yes, because the 3 is outside the function, is it going to be a shrink or a stretch? In other words, will it get shorter or will it get longer and skinnier? Yeah, it's a shrink if A is a fraction. It's a stretch if it's bigger than 1. So what happens here is this. It says 3 times the function. Remember, what does this represent? This is my Y value. So whatever my Y value is, I multiply by 3. So when X is 1, what's the absolute value of 1? 1. 1 times 3 is 3. So there's my new point right there. When X is negative 1, the absolute value of negative 1 is 1 times 3 is 3. When X is 2, the absolute value of 2 is 2. 2 times 3 is 6. So at 2, it goes up to 6. At negative 2, it goes up to 6. So my new graph looks like this. Is it a shrink or a stretch? Well, you took this original graph and you pulled it up. You stretched it. Think of the old Stretch Armstrong toys. You pull them. Yes, you don't remember that. So, but this one, the whole graph stretches upwards because it's an integer. So again, if it's outside, all you do is multiply to the Y values, that value. Horizontal, shrink, or stretch. Remember, whatever happens, horizontal changes happen where? Inside or outside the function? Inside. Remember, anything that happens inside the function is what? Is it the same or is it opposite? It's always opposite. So, in the horizontal shifts, we have a f of bx minus c plus d. If b is, I should say, if the absolute value of b is bigger than 1, we have a horizontal shrink. If your coefficient of x is an integer, that means your graph will be pushed closer. It'll be shorter, narrower. If if the absolute value of b is a fraction between 0 and 1, then we have a horizontal stretch. Okay, wait, it's always opposite. So by shrink, the graph is being pushed towards the inside. By stretch, it's being pulled out. It's getting wider. Okay, get that packet that I gave you. This one. This is example 3. We're going to look at horizontal and vertical shrinks and stretching. This is our original graph. For A, what's A going to look like? A is 2f of x. This graph of s is f of x. So what changes? Again, is it a horizontal or vertical change? It's a vertical. So how do we change this one? What do we do? What is f of x? F of x is what? Is your y value. What this one says is whatever your y value is, multiply by 2. So for the first one, here's the y value. Leave the x alone. That doesn't change anything. And this one here has no horizontal shift. So if we multiply 0 by 2, what do we get? 0. So we still have at negative 5, 0. Nothing changes there. How about at negative 2, 2? What does it become? What are you multiplying by? What is this one multiplying to? This is 2 times y. Yeah, it becomes negative 2, 4. Because I'm taking my y value, I multiply it by 2. The origin stays there. Oh, that's not 5. 5 is right here. Sorry. The next one, I have 2, negative 4. So what does it become? Yeah, it becomes 2, negative 8. So 2, I go all the way down to negative 8. There's my new point. And the last one is 4, 0. So it just stays there. So this one, because it's outside the function, is a vertical stretch. I took the graph and I stretched it. What's going to happen in B? Is a horizontal or vertical change? Which one? It's vertical because it's outside. So what does it tell me to do? It says, and how it's going to be a shrink. So how do I shrink it? Well, whatever my y value is divided by 2. So my y value here is 0. So it just stays there. 0 divided by 2 is 0. The next one, at negative 2, 2, it now becomes negative 2, 1. Because I divide my y value by 2. The origin stays the same. Negative 2, negative 4 becomes what? 2, negative 2. And 4, 0 stays the same. So what have I done there? I shrunk it. I vertically shrunk it. Now comes the different part. It's on the inside, so the horizontal or vertical. It's horizontal. So since it's on the inside, remember, it's opposite. Let me plot those points again. Let me write those down. So for the first point was -5, 0. The second point was -2, 2, 0, 0, 2, -4, and then 4, 0. That's the original graph. I don't need the graph. All I need now is just the numbers. So since it's inside, what does it affect? The X or the Y? The X. What do I do to the X values? Since it's opposite, this is multiplied. So since it's multiplied, I divide. So this is an integer, I divide. So what is -5 divided by 2? -2.5, which is right about there. And the next point is -2, 2. What does it become? -1, 2. So it becomes -1, 2. This one becomes -5/2, 0. The origin stays the same. What does the fourth point become? Yeah, it becomes 1 negative, because the only thing changes is my X value. The Y value stays the same. So it's 1, -4. And the last one, 2, 0. So what have I done to that graph? I I horizontally shrunk it. I can compressed it. So if you have an integer coefficient inside the function, you divide the X values. If you have a fraction in front of the X, what do you do with the X values? You multiply it. Well, by the reciprocal. Why is that? Because here you have your X, you're still dividing by it. But if I have a fraction here, what happens? It becomes a multiplication. Because remember, what's the rule of dividing fraction divided by a fraction? Take the top fraction, leave it alone, and flip the bottom. So if I had X over 3/4, it would be the same as X times 4/3, which is 4X divided by 3. So it's if you have a fraction, you take the reciprocal of it and multiply it to the X value. So my first X value is -5. What does it become now? It becomes -10. Because since this is 1/2, I multiply by 2. So it's -10, 0. The next one, -2, 2 becomes what? -4, 2. 0, 0 stays the same. 2, -4 becomes 4, -4. And then 4, 0 becomes 8, 0. So look at this graph. I mean, now this graph has been stretched horizontally. and the last graph. What happens here? Two things happen. What are they? First, it's a fraction. So what do we do with all the x values? Multiply them by 2. So that's what this one, that's what we did over here on this one. Now, what does the negative make me do? What the negative does, it's a horizontal reflection. I now flip it across the y-axis. Or here's another thing. I will take all the x values, change the signs. So this one at negative 10, 0 becomes positive 10, 0. Negative 2, 2 becomes positive 2, 2. Or positive 4, 4, I'm sorry. Positive 4, 2. That's negative 4. It becomes positive 4. 0, 0 stays there. 4, negative 4 now becomes negative 4, negative 4. And then 8, 0 becomes negative 8, 0. So if you have a negative coefficient inside there, then it just, all it does is flip across the y-axis. That's the hardest part. If it's outside the function, it's just easy. Just multiply the y values by whatever it is, and then you have it. If it's a integer, it gets higher. If it's a fraction, it gets lower. Inside the function, it's always opposite. So if I have a fraction, I gotta flip it and then multiply. All right. So that's that example. Let's look at example 4. This is how you'd see it in a textbook or in a test or a homework. So it gives you the function. What's the first thing we got to do here? Is there a horizontal shift? Where? How many spaces? It's to the right 3 spaces. So what we have to do is each one of these dots here, move them to the right 3 spaces. So negative 5, 0 becomes negative 2, 0. Negative 2, 2. What this thing says is you add 3 to all your x values. So I add 3 to this one. I add 3 to this one. I add 3 to this one. So that one becomes negative 2, 0. This one becomes negative 1 or positive 1, 2. This one becomes 3, 0. This one becomes 5, 4, 5, negative 4. This one becomes 7, 0. So I shifted to the right 3 spaces. So that was my first one. I did x minus 3. Then what do I do? The next thing I do, I put a 2. Remember, treat the signs and the numbers separately. So there's a 2 out in front. What does that make me do? If it is 2 outside the function, what does it make me do? Yeah, so yes, it's a vertical stretch because it's an integer. But what values do I change? The y value. Because it's vertical, I only change the y values. So here, I multiply each y value by 2. This is the first one is that add each x value by 3. Just treat the signs and the numbers separately. That is one thing I have to break you guys of. So my y values. The first one is at negative 2, 0. 0 times 2 is 0. So it stays there. The next one is at 1, 2. Multiplied, so it's at 1, 4. Next one's at 3, 0. It stays there. Next one's at 5, negative 4. So I multiply it by 2. So it's 5, negative 8. And then at 7, 0, it stays the same. So it's a vertical stretch. It's a vertical stretch because it's an integer. It's greater than 1. It gets skinnier. All right. Looking at this transformation, the next thing, I've done the inside, I've done the 2. Now we're going to do the negative 2. Now I do the negative 2 f of x minus 3. So what does that negative make me do? What does this negative make me do? Change the y values, change the sign of the y values. Because since it's negative, whatever is my y value, I change the sign. So for the first one, it's at negative 2, 0. It stays the same at negative 2, 0. Then I have 1, 4. It becomes what? It becomes 1, negative 4. This one becomes 1, negative 4. Three, 0 stays there since nothing changes. This one is 5, negative 8. So what's my new point? If this is 5, negative 8, what's my new point? 5, positive 8. So go to 5, go to positive 8. And the last one's at 7, 0. It stays at 7, 0. Then the last transformation is I add 1 to it. I have negative 2 f of x minus 3 plus 1. The next thing I have is this one. What does it do? Yeah. shift up one space. So the entire graph. Basically, when I say shift up one space, I said add one to y value, each y value. What this one says is add one to each y value. So the first one was at -2, 0. It now becomes -2, 1. I add one to the y values. The next one is at 1, -4. It becomes 1, -3. It was 2, 0. Now it's 2, 1. Oh, no, 2, 1, 3, 1. I'm sorry. 3, 1. Next one was at 5, 8. It becomes 5, 9. And the last one's at 7, 0. It becomes 7, 1. So this entire graph just shifts up one space. That's how you do these transformations. You have to do them piece by piece by piece by piece. And treat the signs and the numbers separately. Take your time with them. Any questions about it? It'll take practice. It'll take lots of practice. And again, you have to understand what your graphs look like.
I didn't really understand why we multiply the x value. So, or when we divide it when it's multiplying.
Because the horizontal, anything happens inside is opposite. Because if it's on the inside, let's just look at that. If I had 2x, yeah, and the reason being because what my original graph was, my new point is going to be this. Because it's opposite. If I had 2x equal 1, then x equals 1/2. That's again, anything on the inside is always opposite. So if it's multiplied, you divide. How do you mean? Mm-hmm. You mean this too? Well, no, because order of operations, multiplication is more important than addition. It's, the horizontal shifts first because that happens because x is independent variable. We have to first fix the x. Once we do that, then we get the y value. This is the y value. But what happens next? Because this is multiplied, I do that. That's multiplied, I do that. And then lastly, I do the vertical shifts. Good question. Yes, it all has to do with order of operations.
What if we have like 2x minus 3, or let's say 4 minus 4? Does that shift on the horizontal line? It will be.
Are you
-2?
inside the function?
Yeah. Like -2, or it will be.
Yeah.
It will be
Same thing.
-2 or.
Take the inside, set it equal to 0. That's your horizontal shift.
So you have to solve the equation then.
Right. So it's good question. Yes. So, and this is to horizontal shift, it's always take the inside, set it equal to 0.